Hi, good day to you, everyone. Today we'll be talking about assignment 3's video presentation, and the topic for today is a correlation study of the variables in the Tetuan power consumption.
Brief introduction on Tetuan is that it is a city in Morocco with a population of 380,000 as of 2014, and by now it will have exponentially increased, and so too would their carbon footprint. And with that, there would be an ever increasing temperature due to global warming, and the power consumption in order to maintain a normal lifestyle would be necessary to cope with it. The objective of this study is to study the correlation of the temperature of day with the power zones, and also further we are going to validate the strength and the correlation of the model that we are generating. So with this data set, it comes with 9 attributes and 52,000 observations, and of the attributes as shown on screen, the notable ones are temperature and the power zone consumption. So for the infographic of the distribution curves, as you can see that they're roughly normally distributed with the exception for zone 1 being double peaked and zone 3 being left skewed, which means that there are a higher number of lower value data, and zone 2 is having the most strongest normal distribution. Moving on, we have the infographic for QQ plots, and roughly for all three zones they are almost the same, that with the exception for zone 3 that it is positively skewed, so it supports our left skewedness in histogram for zone 3. With the objective that we have already defined earlier, we are also going to be testing the hypothesis of correlation between the two attributes. So we will be testing the null and also the alternate. So the null being that there is no correlation between the attributes, and the alternate being that there exists a correlation. We have 4 correlations to choose from, as you can see, and why we have chosen the Pearson correlation is for the linearity of the data set and the quantitative quality of it. The assumption that we have made is that the data is representative of the sampling, and one variable would impact the other variable, and for the variables that are represented in the normal distribution we have already proven earlier, and we are going to prove in later that there are no extreme outliers in the data. As you can see, we have rejected all 3 null hypotheses in favor of the alternate, so this would tell us that there is a relation between temperature and power consumption. We have also generated a heat map for us to actually have an overview of all the other existing attributes, and with that we can actually see that for temperature and power zone consumption they are quite related, and we are actually in the right direction. We would be disregarding the other attributes as actually they are dependent on other attributes as well. In plotting our regression analysis, we do take note that there is an unsymmetrical pattern with right skewness, so this would actually indicate that the model is a weak prediction of the correlation. With the coefficients we have generated from our output, we have generated our models, and it does indicate a positive linear relationship, with zone 2 having the weakest linear relationship. From this output table, we can see that the multiple R squared value does tell us that our values indicate a rather weak fitting of the model, with zone 3 having a slightly better fitting of the model. However, the F statistic and P value does support our rejection of the null hypothesis in favor of the alternate. In performing the regression analysis, we are also going to be proving the assumptions that we have made in terms of linearity, homozygosity, independence, and normality, which are going to be further discussed. Here we can see the regression diagnostic that we've run for the first section of residual versus fitted. We can see that it does follow a linear relationship. However, with the exception of zone 3, which is not supporting our model due to the parabolic curve, we can say that we could probably disregard it. And for the residual QQ plots, we can say that our residual values follow a normal distribution. Looking at the second part of regression diagnostics, we can see the third plots that we have generated of the scale location plot. So what this does is that for the red line that has no particular shape, it does say that homozygosity is satisfied for this regression. And for the last part of the plots, residual versus leverage, we can see that Cook's distance is not even visible in any of the graphs. So this does tell us that there is no influence of outliers in our data and on the regression that we have done. In conclusion, we can say that there exists a correlation between the variable of temperature and power zone consumption. However, it is a weak relationship, and as we can see, zone 3 indicates a slightly better relationship. However, it is still low, and in performing the regression we can reject further strengthen our rejection of the null hypothesis. And with the normal distribution of the residuals in this data, it could also indicate to us that there is nothing abnormal about the data set that could influence our findings. To you who are watching, I would like to thank you for taking your time to watch this video, and I hope that it has given you some enlightenment on what I have found in this data. And with that, my name is Joshua Ashrinraj. I'm a Sunway student, and I hope you have a great day ahead.